Okay, so yesterday we did a couple examples, I do believe, examples 1 and 2. So we talked about in example 1, how they were proportional because all of their unit rates were the same. We checked in example 2, how they were non-proportional because all their unit rates were not the same. So I want you to just practice checking to see if it's proportional on page 29, number 3 and 4. I'm going to give you just a couple minutes to try numbers 3 and 4. Again, we're filling out the tables and then checking for proportionality. So once the tables are filled out, then we can say, you know, whatever this is divided by that, whatever this is divided by that, whatever this is divided by that, whatever this is divided by that. If they're the same, it's proportional. If they're not the same, it's non-proportional. Okay, give those a try. Okay, so when we're filling out the table, we have to read and figure it out. The Fun Center rents popcorn machines for $20 per hour. In addition to the hourly charge, there's a rental fee of $35. So for 1 hour, it would be the $20 plus 35, which is what? 55. For the 2 hours, it's 2 times 20, which is 40 plus 35, which is 75. So each of these, we are adding 20 because it's $20 more for each additional hour. So this becomes 95 and this becomes 115. Now, if I were writing these out, 55 divided by 1 is 55. 75 divided by 2 is like 3750. 95 divided by 3 is like 31 point something. So are these changing or staying the same? Are these changing or staying the same? They're changing, right? So this is non-proportional. I'm just abbreviating. Number 4, Jean has $280 in her savings account. Starting next week, she will deposit $30 in her account every week. So if she already has $280 after the first week, she's at $310. And every week after that, we're adding 30 to it. Is this a proportional relationship? It is. Totally. Well, this right here is 310 divided by 1, which is 310. If our unit rates are not the same, it is not a proportional relationship. It's 270. It's already different, so we could stop there. 400 divided by 4 is 100. So is this a proportional relationship? No, this is non-proportional. No, just because we're adding each one doesn't make it proportional. If we were multiplying by something, it would be, right? Up here, we were multiplying each one of these by 250. Here, it was a little bit trickier. It was like 3 halves. A little weird. Okay. We are gonna head on back to learn some more. I know it's Friday. Okay. I'm so tired. All right, I'm gonna go back to page 24. Remember, not only do I record, but I also am here on Zoom if you are ever gone and want to join us. My 7th grade classes are during 4th and 5th hours. You can also access it through your Clever. We are on page 24. That would be a long ways back. We're on page 24, and in our calendar on your dashboard, you'll find this here. So we launched the lesson and we got through our exploration in example 1 and 2. So now we are on example 3. We're going to identify the constant of proportionality. So we've learned, oh, does it skip this word? Must be. Maybe we're just missing something. So the winner of a jump roping competition jumped 124 times in 20 seconds. So we're actually skipping the learn, but let's look at the learn real quick before we move on. Let me stop sharing that. So we've learned that two quantities are proportional if the ratios comparing them are equivalent or constant. So the constant ratio is called the constant of proportionality. We've been talking a lot about constant of proportionality. The constant ratio is called the constant of proportionality. The constant of proportionality has the same value as the unit rate. So creators of a stop motion animation can film 24 frames per second. Frames per second. Remember that per is in place of a fraction bar or a division symbol. So this is frames divided by seconds. Frames per second means frames divided by seconds. That's how we're going to find our unit rate. The table shows the number of frames captured over 1, 2, 3, and 4 seconds. So if we're looking for the constant of proportionality, we want frames per second. So 24 divided by 1 is what? 24. Is 48 divided by 2 also 24? Yes. Is 72 divided by 3 also 24? Yes. Is 96 divided by 4 also 24? Yes. So it's staying the same. It's constant. That's why it's our constant of proportionality. So what is the unit rate? So it would be 24 frames per second, right? Also 24. Because the constant ratio is 24 over 1, the constant of proportionality is 24. And the unit rate is 24 frames per second. So these two things are the same. All right, so hopefully that helps us with our example as we move forward here. Here we are. So the winner of a jump rope competition, do you see where we are still on page 24? The winner of a jump rope competition jumped 124 times in 20 seconds and 186 times in 30 seconds. What is the constant of proportionality? So how are the constant of proportionality and the unit rate related? How are they related? What did we just say? They are constant rate of proportionality and unit rate. They are the same thing. Okay, constant of proportionality and the unit rate are equal to each other. They're the same. So if we can figure out unit rate, which we all should be able to do, we can figure out our constant of proportionality. Here we go. We're going to drag the appropriate values while we fill this out to form equivalent ratios so that each ratio has a denominator of 1. Hold that thought for 1. Okay, so this tells us we have 124 jumps in how many seconds? What did the question tell us? 124 jumps in 20 seconds. Look at your page, guys. So we're going to drag. Oh, the drag is up here. Put that in the way. Sorry. This to 20 seconds. So what do we need to put there in our box? We're going to write 20 seconds. Do you see that? Need me to zoom in? Oh. Now, in order to get it out of 1 second, we have to say 124 divided by 20. So if you need a calculator, now would be a great time. Or I'll show you how to move a decimal. So how can I divide 124 by 2? Yes, 2 goes into 12 6 times and 4 2 times. But since I'm also dividing by 10, I have to move my decimal to the left one. So 6.2 jumps per second. Yeah. Still jumps per second, right? Oh, look, they gave it to us. I wasn't even paying attention. All right, now the second part of our question says 186 times in 30 seconds. So I'm moving this 186 here. We're going to follow the same thing. If I divide 18 by 3, so I needed to write 186 jumps here. If I'm dividing 186 by 3, I'm saying 18 divided by 3 is 6. 6 divided by 3 is 2, and then when I divide it by 10, I'm moving the decimal place over once to the left. So this is also 6.2 jumps per second, okay? I'm just going to reset for my next hour. Now, if the relationship was not proportional, would there be a constant of proportionality? If it's non-proportional, is what we're multiplying by them constant? No, it changes. So there would not be what? Please don't bring down my wall. Thank you. All right, so no, right? There would be no constant of proportionality because we'd be having to multiply them by something different, something that does not stay the same. Something that does not stay the same is not constant. All right, try this check. It begins on page 25. The cost of a birthday party at a skating rink is proportional to the number of guests. The skating rink charges $82.50 for 10 guests. The choices show the number of guests and the total cost for 4 different parties that were hosted at different locations. Select each party that was hosted with the same constant of proportionality or unit rate as the skating rink's unit rate. So what would the unit rate be? We would have to divide $82.50 by 10 guests. So unit rate would be for 1 guest. Remember, when we divide by 10, we're simply moving the decimal plate over over 1 to the left. So $8.25 per guest. Which one of these is also equivalent? If you want to use a calculator, you may. So we want 8 1/4 times 12, 8 1/4 times 8, 8 1/4 times 15, 8 1/4 times 6. See which one of those makes this work. You may definitely grab a calculator if you need one. Go. So when we're checking for proportionality, we're seeing which one of these has a unit rate of $8.25. Or in this case, it's really a unit price, right? So we're going to say 99 divided by 12. That's $8.25. So does that work? Yes, that works. Or you could say, is 12 times $8.25 equal to $99? Yeah, so you could do it either way. Is 8 times 52, that's not what I want to do, is 8 times $8.25 cents 52. We should know right away by looking at it, 8 times 8 is 64, so that wouldn't work, right? So we put a check mark here for 12 guests. 8 guests for $52 was not the same unit rate. They must have gotten some sort of discount, right? So 15 guests times the $8.25. That's $123.75. So their unit rate was actually 97.5 divided by 15. They're actually only being charged $6.50 per person, per guest. So let's try this last one. This one might be, right? Because we know 6 times 8 is 48, and that's pretty close. So 6 times $8.25 is indeed $49.50. So just the first and the last ones. Okay. Now, here is our extra example 3. So we're going to use our extra space here. A fundraising organization paid $163.80 for 420 wristbands. The cost of the wristbands is proportional to the number bought. Which of the following has the same constant of proportionality? So let's figure out how much it is for each one. So in order to find our unit price, we're going to take our price, 163.8. There's our price divided by 420 bands. So if we put that into our calculator, 163.8 divided by 420. Sorry, it's easier to see when I turn that on. And that equals 39 cents a band. So which one of these was also 39 cents a band? So 80 times 0.39 is 31.2. Is that $31.20? Man, is the answer always A? Well, I feel like it might be. Let's check the other ones just so you remember how to do it. So 520 times 39 cents a piece. That would be $202.80. And that's not what it was, right? They got 150.8. Now let's try 315 times 39 cents. And that's $122.85. So they charged them more than the other unit price, maybe. And then 240 times 0.39, which is 39 cents, $93.60. So they actually saved money there. So the answer here would be A. So this is the same as 80 wristbands charging $31.20 for 80 wristbands. These are equivalent. Sorry, my got a little wild there. Okay, so let's try a couple of problems in our practice. Remember, our practice is on page 29. Now we should be able to look at numbers 5 and 6. So we are going to do these two and go over them. So this is the last thing you have to do this week, numbers 5 and 6. All right, so where do we start? We have to find the unit price because that is our constant of proportionality. So $12.50 for 25 game tickets and $17.50 for 35. Let's see if there is a constant of proportionality. So 12.5, oops, 0.5 divided by 25. This is 50 cents per ticket. So let's look at this one. This is 10 more tickets, so are we expecting it to be $5 more? I would say yes, but if you wanted to check that out the same way, you could say 1750 divided by 35, also 50 cents. So the constant of proportionality is 0.5, or 1/2, or 50 cents, right? A baker in 70 minutes. Well, I'm gonna put cupcakes on the top. They ice 40 cupcakes in 70 minutes. So this is cupcakes, this is minutes. Here, they ice 28 cupcakes in 49 minutes. So let's test here for proportionality. 40 divided by 70 is 4/7. What if I divided these both by 7? It's also 4/7. So for every 4 cupcakes, there's 7 minutes. Or if you wanted to figure out what that is, you could divide 4 by 7. So, or 57 hundredths of a cupcake per minute. So just over half of a cupcake per minute. They could ice. That's pretty impressive. Maybe, I don't know. Guess it depends on how fancy it is, right? So you have a few minutes, make sure you're going back, making sure you're through numbers 1 through 6 on page 29. You should also be through pages 1 through almost all the way through 25. So we just have a couple more pages and we're gonna be applying on Monday.